And now we switch into some trigonometry. We are looking at 6.1, angles in standard position. And we're just talking about quadrant 1 right now. What this is really saying is we're going to take the trigonometry, so katoa, that we've done previously, and we're going to merge it with geometry. And we're going to start slapping our triangles into quadrant 1. This was quadrant 2, 3, and 4. So we're going to just look at quadrant 1 to start with. Before we get started, let's just remind you of your trigonometry that you know so far. We've got a right angle triangle. So all the trigonometry you've done has to be a right angle triangle right now. Next to the angle we're talking about is the adjacent side. Across from it is the opposite side. The hypotenuse is always the longest side, and it's always across from the 90-degree angle. The trig ratios are just saying, what is one side compared to the other side? What is the relationship? What's the ratio between the two? So we've got sine is the opposite over the hypotenuse. We've got cosine being the adjacent compared to the hypotenuse. And then we've got our tangent being the opposite compared to adjacent. And we brought that together and we said, oh, how are we going to remember it? Looking at the first letter of each. And we went with so, ka, toa. You could also use other things, but that seems to be the one that most people are using. So let's use this and complete the relationships here. Sine of angle D. So we're talking about angle D. The sine is our opposite compared to our hypotenuse. So the opposite side is 8. Well, let's write down opposite compared to hypotenuse. So 8 compared to the hypotenuse, and the hypotenuse is 17. We want to take that to lowest terms. Oh, it is lowest terms. That's where we stop. That's the ratio, the relationship. Still referring to angle D, we've got cosine. Cosine is the adjacent compared to the hypotenuse. So we've got our adjacent, which is 15, compared to our 17 hypotenuse. So 15 over 17, again, is that lowest terms? Yeah, that's where we would stop. And then we've got our tangent opposite compared to the adjacent side. The opposite side is 8. Compare that to the adjacent side, which is 15. So we've got 8 over 15. And again, lowest terms? Yes, it is. Now we're ready to get started with the questions there. Air traffic controllers use radar to track aircraft. A tracking ray rotates around the center of a radar display and shows a blip as it identifies an aircraft's position. The blip indicates the distance and direction of the aircraft from the radar antenna. Radar antenna, right in the center. One aircraft is 100 kilometers due east and 50 kilometers due north. Okay, so to the nearest kilometer, what is the distance between the aircraft and the radar antenna? Well, we've got a right angle triangle. Trigonometry works for a right angle triangle. There's also something else that also works in a right angle triangle. Pythagorean theorem. C squared equals A squared plus B squared. So we've got a right angle triangle here. We've got our A, we've got our B. We're looking for our C value. So let's plug it in and work it through. So I'm going to change C to D for distance, because that's really what we're looking for. So I'm going to say D squared is equal to 50 squared plus 100 squared. So d squared is equal to 50 squared, that's 2,500, plus 100 squared, that is 10,000. Add them together, that gives us 12500, and that's still d squared. But I want to know d, so we're going to square root both sides. Now, when you take the square root, it's plus or minus, except when we're talking about distance like this. That distance is just a positive distance. So d is equal to the square root of 12,500. That's your exact form. Punch it into your calculator because they had said, let's go to the nearest kilometer. So d is approximately equal to 111.8, which to the nearest kilometer is 112 kilometers. Now we're looking for the angle between the two of them. That brings in our trigonometry. So we have all three sides. However, use the sides that they give you. They gave you the opposite and the adjacent. Use those two sides, not your value that you've calculated. Especially since you did round that number. Don't use a rounded number ever. So we've got opposite and adjacent. We're going to use the tan ratio. So the tan of angle R is equal to the opposite, which is 50, divided by the adjacent, which is 100. Hey, that's 0.5. That's 1/2 there. So then, if I want to solve for the R value, the angle, I need to get the tan over to the other side. You can't just divide the tan. You got to take the inverse tan to move it. So angle R is equal to the inverse tan of 50 over 100. You could put 0.5 if you would like. I'm just going to keep it as 50 over 100. Punch that into your calculator in degree mode. Make sure right now that you have changed your calculator into degree mode. And if you can't remember how to do that, click mode on your calculator. It's up at the top left side. And then make sure that degree is highlighted and hit enter. Punch it into the calculator as you see it there. So then R is equal to approximately 26.6 degrees. And they said, they didn't tell us to the nearest. Let's just go to the nearest degree then. So R is approximately 27 degrees. The last example is a really good indication of how we're going to be using our standard position, putting it onto an XY coordinate plane. On a radar, that spins, and it goes around the center. That is what we're going to be doing. So what we're going to say then is we've got an X value from the point. We've also got a Y value on that point. And then we've got this R value. That R value is representative of the radius of this circle. And that circle is rotating around. So first question, express R in terms of X and Y. Well, if we're just looking at R and X and Y, we can use Pythagorean theorem. R squared equals X squared plus Y squared, but it asks for R, not R squared. So R is equal to the square root of X squared plus Y squared. First one done. Second one, the value of theta. We can see theta is right in here. Theta is always going to be at the origin. We're always going to be looking at our angles inside the triangle between the x-axis and that R line. So the value of theta in terms of x and y. Hey, we've got x, we've got y. Those are opposite and adjacent. We're going to talk about the tan ratio. So we've got the tan of theta is equal to opposite, which is y, over the adjacent, which is x. But we want theta, not tan of theta. Got to take it to the other side. Inverse tan of y over x. Now we get tricky. we're looking for the x value, but the x value we want to talk about with r's and thetas. Okay, well, we've got the x and an r. That's adjacent and a hypotenuse. Ooh, so that's cosine. So we can say cosine of the theta is equal to the x over the r. And we want to isolate x now. So we'll take our x, multiply our r up, and we get x is equal to r times the cosine of theta. Now we've got to do the same thing with the y value. For the y value, we're looking at our opposite, and we want it in terms of r and theta again. So we've got opposite and we've got hypotenuse. So then opposite hypotenuse, oh, that's sine. Sine of theta is equal to the y, the opposite, over the hypotenuse, which is the r. Again, do the same thing. Let's multiply both sides by the r. That one cancels off. And we get left with y is equal to r times the sine of theta. That is going to become real handy later on as we move through in trigonometry. So then the coordinates of point P on the coordinate plane can be described by its distance r from the origin, O, and the angle, theta, that OP makes with the positive x-axis. Lots of words here. When the angle is between 0 and 360 and is measured counterclockwise from the positive x-axis, we call that standard position. So that's the definition of standard position. I'll show you what that means. Standard position means we put it on an xy coordinate plane. We are going to start on the positive x-axis. We are going to rotate in a counterclockwise direction. And we're going to stop when we get to what's called the terminal arm. So that's going to be our terminal arm now. So as soon as you see the word standard position in any question, all it's doing is it's telling you the rules that you're playing the game by. And that's start at the positive x-axis and go counterclockwise from there. Also, bring your triangle back down to the x-axis. Always to the x-axis, never to the y-axis for standard position. All right, here we go. We got the game to play here. Point 3 and 4 is on terminal arm of standard position. Those are the rules we're going to follow. So start by sketching it for yourself. 3, 4. No. 1, 2, 3, 1, 2, 3, 4. There's our point P, 3, 4. Connect from the origin to there and draw your triangle back down to the x-axis. The angle we're talking about is in a counterclockwise direction. And we know that this side is x, which is 3. And we know this side is the y, which is 4. So we go on the x-axis 3, we go up 4. And then we have our r, radius of the circle. Find the distance r. Oh, that's what we've just done. That's Pythagorean theorem. So r squared is equal to x squared plus y squared. R squared is equal to 3 squared plus 4 squared. 3 squared is 9 plus 16. So r squared is equal to 25. Square root both sides. And we get r is equal to 5. Be careful here. If you take the square root, it's plus or minus. But if we're talking about the radius of a circle, it always must be positive. So r must be positive. Determine all the primary trig ratios. That's so katoa. So we need to start with, let's look at our sine. Sine of theta theta's in here. I do a written theta. That's the printed version. So theta is equal to opposite over hypotenuse. So the opposite side is 4. The hypotenuse, hey, we just found it. That was 5. Take it down to lowest terms and leave it as a fraction. Cosine of theta now. Cosine's adjacent over hypotenuse. The adjacent, that's the 3. The hypotenuse, that's what we found, 5. Take it to lowest terms, it is, so 3/5. Tan now. Tan. Toa. Opposite over adjacent. So the opposite side is 4. The adjacent side is 3. It's 4/3. We now have 3 trig ratios that we could use to solve for our theta. But I'm going to recommend that you use the numbers that they gave you. They gave you 3, they gave you 4. Let's use the one that uses those, not the one we calculated. So I'm going to use tan this time around. So then tan of theta is equal to 4/3. This time we're going to solve and isolate our theta value. So let's take the tan over to the other side. The only way to do that, inverse tan. So when you're looking for an angle, you do the inverse of 4/3. Punch that into your calculator in degree mode. And you get approximately 53.1301 ... And let's go to the nearest degree. That's what they told us. So theta is approximately 53 degrees. All right, let's connect slope with trigonometry now. Want to remind you what slope is. Rise over run. Look at the triangle. We just did that question number 1 there. Look at the triangle. Talk about rise and run and see how that is related to trigonometry. Now, some people find this section here when we start talking about navigation a little bit trickier. Okay, so you might need to go through this a couple times for this part. Trigonometry is essential for navigation. A direction can be described by relating it to 2 of the compass points, north, south, east, and west. So for example, if we're talking about west, 30 degrees south, what that means is go west, first of all, due west, and then go 30 degrees south. And in the same way, if we were going west 40 degrees north, start by going west, and then come up 40 degrees in the north direction. Now for the next question, I'm going to let them explain their example too, because it is a bit tricky for some people to start with this. So let them explain their example too, and then I'll do our example too.
An aircraft made an emergency landing 200 kilometers from an airport. Its heading from the airport was east 50 degrees north. The land-based rescue team has to travel east, then north to get to the aircraft. To the nearest kilometer, how far should the team travel in each direction? I'm going to draw a diagram to help me solve the problem. I'll let the origin, O, represent the position of the airport. The aircraft's heading from the airport was east 50 degrees north. So from due east, I'll rotate 50 degrees toward north. I'll use P to represent the position of the aircraft. The aircraft landed 200 kilometers from the airport. So the length of OP is 200 kilometers. The distance due east is the x-coordinate of P. I'll use the equation x equals r cos theta to determine the x-coordinate. R is the distance from the airport O to the aircraft P, so R equals 200. Theta is the angle that OP makes with the positive x-axis, so theta equals 50 degrees. So x is approximately 128.5575. The distance due north is the y-coordinate of P. I'll use the equation y equals r sine theta to determine the y-coordinate. R equals 200 and theta equals 50 degrees. So, y is approximately 153.2088. The team should travel approximately 129 kilometers east, then approximately 153 kilometers north to get to the aircraft.
Thank you, lady. That was well explained. Let's look at ours now. Forest ranger sees smoke rising from a point that lies east 40 degrees north. So let's draw that. Let's see what it looks like. So always start all of these with your drawing. We first of all go east. So this is north, south, east, west. We're going to go east and then 40 degrees north. So we're going to be right there. Okay. She estimates that the distance from the ranger station is about 30 kilometers. So that means we've got 30 kilometers here. The firefighters at the ranger station have to travel east and north to get to the fire. To the nearest kilometer, how far should the firefighters travel in each direction? We better put our 40 degrees here. And let's make our triangle. Always to the x-axis. So we've got to find our x-coordinate and our y-coordinate. We had that little formula, x equals and y equals the r cos theta and r sine theta. You can use that, or you can just go right back to using cos and sine right from the beginning if that works for you as well. So I'm going to go right back to the beginning just so you don't have to memorize that little formula. So if I'm looking for the x value, I have the hypotenuse and I'm looking for the adjacent. Adjacent and hypotenuse, oh, that's cosine. Cosine of theta equals adjacent over hypotenuse. Okay, so then I'm going to say cosine, I know the angle, oh, that's 40 degrees, is equal to the adjacent, which is my x, over my 30 degrees. Multiply the 30 up and over, and we get that r cos theta like we did before there. So then x is equal to 30 cos 40 degrees. We punch that directly into the calculator, and we get x is approximately 22.9813 dot dot dot. Let's round that. That's going to take us to approximately 23 kilometers. Now our y value. We're going to do exactly the same thing, but this time we're going to use the adjacent and the hypotenuse. That's sine. Sine theta equals the opposite, over hypotenuse. So we got our opposite, which is the y. Let's go plug it in. Sine of 40 degrees equals y over, that's 30 degrees, or 30 kilometers. Multiply our 30 up and over. That cancels off. We get left with y equals 30 sine of 40, or you could have used r sine theta. Plug that straight into your calculator. Y is approximately 19.2836 dot dot dot. Rounding it, y is about 19 kilometers. So how far should they travel? They should travel, it's a written question, we should put it into a written answer. They should travel 23 kilometers east and 19 kilometers north. And then go fight that fire. The next page there, page 430, takes us through combining Pythagorean theorem and trigonometry together. We've already talked about x being r cos theta, y being r sine theta. So now we can bring it together and say r squared is equal to the x squared plus the y squared. Square both of them, the r squared and the cos squared. And now we divide everything by r squared. This one cancels off. This one cancels off. That one cancels off. We get left with cos theta squared plus sine theta squared equals 1. And notice what they do here. Taking that squared and just putting it inside, just so we don't have to put brackets. That's just the notation that they use. And now I'm introducing you to the first of 3 exact value angles that you're going to use, special triangles. And that's 45 degrees. If you have 45 degrees there, that means that you've got 45 degrees up here as well. Hey, that's an isosceles triangle. And if the 2 angles are the same, that means the 2 opposite sides from there are going to be the same, making those the same length. Let's call it 1 for ease. If we use Pythagorean theorem, let's find the r squared, the r value. So let's look for this. Well, that's OP. And you can see, working it through here, that you come up with the square root of 2. That gives us a special triangle of 45 degrees, 1, 1, root 2. Now we can do the exact values of 45 degrees. So the exact value of tan of 45, not in a decimal form, is equal to 1. Sine of 45, that's equal to 1 over the square root of 2. The opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and it's also going to be 1 divided by the square root of 2. And we leave it as such, though not taking it to a decimal. We can just say the sine of 45 is exactly 1 over root 2. We'll come back to that a lot as we're going through. Now do a little bit of playing around. What if we would have changed, instead of using 1 for our side length on the isosceles triangle, what if we used 2 or 3? Would that change the values in lowest terms of those ratios? And finally, finish off to discuss your ideas so that we can discuss those in class. All right, have a good one.